you want to decrease the mortality rate of children? The CDC has stated that there have been 3 major plagues over our history. The first one being the Justinian plague, the second one being the Black Death or Great Plague, the third one being the modern plague. The Justinian plague was recorded to have killed over 25 million people. The Black Plague, or the Black Death, was said to have killed 60% of Europe's population at the time. The modern plague was recorded to kill nearly 10 million people. Today, plagues are cured with a simple antibiotic, and now there is a new approach to health on the horizon. My name is Chris, and today we'll be talking about CRISPR. CRISPR is used to insert the DNA from one animal into another or alter a DNA segment of an animal. So, the CDC found that 300,000 people are diagnosed with Lyme disease every year in the United States alone. Also, the World Health Organization reported 219 million cases of malaria in the year 2017. In addition, the average wait list for an organ transplant is up to a year, and CRISPR could be the solution to all of these problems. So, CRISPR gives humans the ability to insert the DNA from one animal into another. This can include cutting out segments of DNA, again switching the DNA of animals, or just simply altering small parts of a larger segment of DNA. Now, it has been proven that these genetic alterations will proceed into the offspring. As shown on the PowerPoint, by changing the genes of just one mosquito and breeding it with a non-altered mosquito, it's shown that by the 4th generation, all of the offspring will carry the altered genes. Now, so what if we could just solve all of our problems with the wave of our hand in the safest way possible? CRISPR could be that solution. With CRISPR, you're not killing millions of animals, there's no negative side effects, and there's no unethical procedures. It's making an animal adapt to be immune to something. And then once that immunity is established in just a couple of animals, then you let the natural process of breeding take over, and that gene will spread through the species. So first, we're going to talk about how CRISPR can be used to reduce the transmission rates of malaria and Lyme disease. The second thing we're going to talk about is how CRISPR can be used to increase the amount of organs available for transplants. So, to start off, we're going to talk about malaria and mosquitoes. At Johns Hopkins University, they're currently using CRISPR on mosquitoes to make them immune to the Plasmodium parasite, or the parasite that carries malaria. How this works is pretty much these parasites are bred in mosquitoes, and with CRISPR, they'd be making them immune to the parasite. So now when mosquitoes bite people, they are no longer able to transmit malaria. Now, malaria does kill 500,000 people per year, and children are even more vulnerable. As a story, Justin Wren is a retired professional fighter who now spends his time building wells for the pygmies in Africa. Across his multiple trips to Africa, he has contracted malaria 3 times. And now this is a full-grown human man, and he has a much more developed immune system than a 5-year-old child. And yet, doctors still said that when he had malaria, he only had a 50% survival rate. Moving on to the next thing, which would be at Massachusetts Institute of Technology. They're using CRISPR on mice to try to rid Massachusetts of Lyme disease. How this works is ticks are the actual vectors of Lyme disease, but they use mice as a reservoir to breed the bacteria that actually transmit Lyme disease. So, how they're using CRISPR is if they make the mice immune to the bacteria, when the ticks attach onto the mice, they're no longer able to take that bacteria with them when they attach on the humans. Now, try to put yourself in the shoes of a mother living in Nantucket, Massachusetts, where a quarter of the population is affected by Lyme disease. You want to let your kids go out and play in the backyard, but the risk is too great with all the mice running around, and those ticks would be able to easily attach to your children. Now, with CRISPR, that idea is in the past, because those mice are now all immune to the Lyme disease, and those ticks can no longer transmit the disease to your children. I know most of you are college students in here, so let's think about studying abroad, which does sound like a great idea until you think about these 2 diseases that I just mentioned, which are easily transmittable, but with CRISPR could be a thing of the past. Not only can CRISPR reduce the transmission rates of malaria and Lyme disease, but it can also increase the amount of organs available for transplant. Starting off, a scientist, Winning Quinn, has been using CRISPR to remove the markers in pig organs. Now, what I mean by this is these are the markers that the human immune system uses to identify foreign cells. For example, how our immune system works is when a foreign object enters our body, for example the flu, it realizes the foreign object and now it sends cells to destroy that foreign object. This is what happens in transplants a lot of the time. They get a pig organ transplanted and then the body recognizes that as a foreign object, and so cells go and destroy that object, which causes rejection rate. Now, with CRISPR, now those pig organs would go under the radar. They would not be identified as foreign cells and the body would just accept them, making more organs available for transplant. Now, just a little story. My grandpa actually did have a heart transplant and they used a pig heart. Over the years, the body started rejecting the organ and then he later had a heart attack. But with CRISPR, that would be a thing of the past and his heart would have worked perfectly fine. Now, a company, eGenesis, has been led by Dr. Luan Wang, who has now been working on using CRISPR to remove the Prosin endogenous retrovirus, or PERVs, from pig organs. Another major problem with pig organs is they are susceptible to a lot of viruses, which makes them ineffective to be used in transplants. But with CRISPR, if they were able to make a pig immune, just like the example here, just with one pig immune, after they breed, then you would have a plethora of pigs to use for organ donation, where all the organs would be perfectly viable, because none of them would be able to get viruses. Just as an example, I know everyone in here has had a time where the whole family gets sick. It normally starts with the younger sibling, and then moves on to the parents, and then the whole family's sick. So just try to think how fast that moves throughout a house, maybe in a whole week. Now imagine if you just put a sick organ into someone else's body, how fast that disease would spread throughout the whole body. That is kind of the threat with pigs that are unimmune to viruses. But again, with CRISPR, all of the pig organs would be immune to viruses and it would open up multiple options. Also, 1 in 10 infants under the age of 4 die on the liver transplant list. 1 in 10, so that could be your current family or future family. Think about that next time. And now, just to recap, again, so CRISPR is used to take the DNA from another animal and insert it into a new animal. And this can be used to reduce the transmission rates of malaria, Lyme disease, and it can also be used to increase the amount of organs available for transplant. So, if you want to decrease the mortality rate of children, support CRISPR and try to spread the word of what it is capable of doing. Now, to leave you with a quote from Albert Einstein: "To raise new questions, new possibilities, to regard old problems from a new angle requires a creative imagination and marks real advance in science." Thank you. Chris, can you turn off the video?